Hey gang, we're going to talk about adding polynomials. This is part of our polynomial unit and it's going to be on our quiz, so it's good to know. Now, a couple things you need to know right off the bat. First thing, alright, that pencil's not going to work. Let me grab a pen. First thing you need to know is you can only add like terms. So, like terms are going to have our terms that have the same variable or variables, and those variables have the same power. So, some examples. X squared plus 3x squared. Because there are x's and they're both squared, we can add those together. In class, I've been talking about making piles. We're basically making a pile of x squareds. So, we never change the variable when we're adding them together because we're making a big group of them. It's like making a group of desks, making a group of pencils, or something like that. We're making a group of x squareds. I got 1 here, 3 here. 1 plus 3 is 4. So, we can only add stuff like that. Now, another example, if you have x minus 3, x as a variable to the first power, 3 is what we call a constant, no variables. So, I can't subtract these because x minus 3 wouldn't make any sense. It's done, it's simplified, you can't touch them because there's no x. With the 3 in x, we don't know what x value is. If we knew x was 10, we could go 10 minus 3 because we'd substitute, we'd be good to go. So that's just a really quick reminder of what like terms are. But when we get to polynomials, if we have something like this, where you have x squared plus 3x plus 2, and we're going to add on x squared minus 3, there are a couple different ways that you can do this, and I'm going to show you a couple different ways. The first way is kind of like the horizontal way. You will put an equal sign first. Since both of these are in parentheses and we can't simplify it anymore, and we're adding this, the x squared minus 3, I'm going to put x squared plus 3x plus 2. Now it's going to be plus an x squared, which is just plus x squared. So plus a negative 3 is the same thing as saying minus 3. Now our next step, we always start with an equal sign because we are coming up with equivalent expressions. Take a look at how many different types of terms we have. We have an x squared term, we have an x term, we have a constant, we have an x squared term, and we have a minus and another constant. So there are 3 different types: x squares, x's, and constants. So what I'll do is I'll start with framework. I'll make 3 groups and add them together. And even if we were subtracting these, we'll add the groups together. And if within the groups, we'll do the adding and subtracting. And if it turns out to be negative, it turns out to be negative. We'll deal with it at a different time. The first group is going to be my x squareds. These are going to be my x's, and these are going to be my constants. So, normally we wouldn't actually write down this line, but we would write down this stuff. And I'm going to put all my x squareds into the first group, x squared plus x squared. And if you're using a highlighter or something, that's going to help because you can now highlight the two terms that you've already used. So now we have eliminated 2 of the 5 terms. Now we look at the terms that haven't been highlighted. Those are still up for grabs. I have a 3x, a 2, and a negative 3. I want my x's. So the only one I see is a positive 3x. So I'm going to put positive 3x here. And I am going to highlight that one. So now for my last one, I have 2 minus 3. And now we do last step to add up everything in our groups. X squared plus x squared is a 2x squared. Positive 3x, I'm going to add plus 3x. And then I have 2 minus 3. 2 minus 3 is a negative 1. Sometimes I put a answer down there. I know that's a negative 1, so it's going to be plus a negative 1, which is going to be minus 1. Now, remember the keys. Discipline and organization. Adding, subtracting, and multiplying is all about discipline. Now, the second way to do this, which I prefer, I'll be honest, I prefer it. If you like this way, go for it. I am not one of those teachers that says you have to do it my way. It's not my way or the highway. We're doing everything the same way. Just like multiplication. There's 3 videos for multiplication, 3 different methods. Find the one you're most comfortable with it and go for it. Master that and you're going to be very successful because all of them are using the distributive property. Now the second way here is more of a vertical way, which requires us to put terms in vertical groups of like terms. I always take the first one here. I take a look at my terms. I have an x squared, I have an x, and a constant. So I'm going to have 3 different terms. So I know I'm going to have 3 different columns. I'm going to take my x squared, put it in my first column. I'm going to have a plus 3x, put it in the second column, then a plus 2. And then what I'll do is, in parentheses for this one, I like my parentheses as you can tell, I'm going to put my x squared and my negative 3 in there. So x squared goes underneath the x squared. Negative 3 is a constant. It's going to go underneath the positive 2. Notice that there's nothing here. If you want to, you can always put a plus 0 there to indicate that there's no x's, or you can just leave it blank. But the whole idea is that we have columns of like terms. Now, our problem said we're adding, so I'm going to add them up. X squared plus x squared is 2x squared. 3x plus nothing is positive 3x. 2 plus a negative 3 is a negative 1. Same answers. It doesn't matter. This works also good when you're subtracting because you could just go x squared minus x squared and get your answer. Just like you would, this is more of the traditional algorithm for adding and subtracting when you have a lot of different terms and numbers that you're doing. I like it so much better that way. This way, there are a lot of opportunities for mistakes because you get a lot of plus signs, minus signs, different terms. If you have poor handwriting, same things happen. Now, let's take a look at a negative. Well, let's do this. Let's go this example. X to the 4th minus 2x squared plus x minus 3 minus x cubed plus x squared plus x minus 10. And what I'm going to do is I am going to not use the horizontal method. I am going to use the vertical method. And the vertical method says, all right, take the first one. And now I notice that I have an x to the 4th, x squared, an x, and a constant. I'm missing an x to the cube or x cubed term. So, since the top is going to kind of dictate the columns, and the first polynomial is going to dictate the columns, what I'm going to do is go x to the fourth plus, now since x cubed would be next and I don't have any, I'm just going to put 0x cubed. And the reason for that, this is more of a placeholder that creates the column. Because obviously there's an x cubed right over here. Alright, so I have x to the fourth plus x cubed minus 2x squared plus x minus 3. And it's all in standard form. Now what I'm going to do is, I know I'm subtracting, so I'm going to put my subtraction sign there. I am going to take the terms from the next one and put them all in the proper column. I have an x cubed, I'm going to put an x cubed there. I have an x squared, I'm going to do a plus x squared there. I have an x, it's plus x, and then that's a minus 10. And now we can say x to the fourth minus nothing. Well, that's going to give me x to the fourth. I have 0 minus x cubed. That's going to just be minus x cubed. And remember, that's just the placeholder, because I needed that column because I knew it was going to be there. Now I have negative 2x squared minus x squared. That's minus 2x squared. X minus x is 0. You could do a plus 0 if you wanted to. Nothing wrong with that. That's just a number, and it's the legitimate answer. Negative 3 minus a negative 10, negative 3 plus 10. So you have 10 minus 3, which is a positive 7. So to rewrite it, just to make sure everything's nice and neat, x to the fourth minus x cubed minus 2x squared plus 7. There's your final answer. So organization is key. If you're missing a term, you still have to account for it in the columns, because in standard form it goes x to the fourth, x cubed, x squared, x, and a constant. So you can't just ignore it because it's not there, because a lot of times it pops up, and it does in that case. Good luck with that. There are a lot of information online about adding and subtracting. You can go ahead and go to it, and you'll be all set. Good luck.